Hi, this is Chong Kim, and we're going to do word search in Haskell. Let's take a look at the input. We're going to have a file that contains a grid of letters and a list of words. A question mark is a wild character, and we'll look for these words either going across diagonally or down. Also, it could snake around. So let's get started. Okay, so the first thing I'm going to do is set this up so that whenever I save the file, well, after it saves the file, any HS file, we'll go into the shell and run the script with the input.txt. Okay, so let's start off with a hello world. See if everything is working, and it is. We see hello over here. So let's take a look at how to get the arguments. The function is called getArgs, and we'll put that into args. Okay, so we need to do it this way because when you're in main, well, when you call getArgs, that is actually in the IO monad. So we want to get a pure list of strings. So like this type is IO list of strings. So it would be something like that. And what we want is just a list of strings without the IO. And so when you do this, this takes the IO out and this becomes just a string. Okay, so we need to import that, the system environment, so that we can get the getArgs function. And we can print it out. So let's see. And we're going to print it out using show. And that'll take this data structure and turn it into a string so we can print it out. Okay, we see that it's a list, and there's another function called read file, and we're going to pass it the head of args, and that will be some type of string. So let's take a look, and we see that we are able to read it in. The next thing we're going to do is split it up based on this blank line, the new line, new line. This is a blank line, so we're going to separate the grid of letters from the list of words. So we're going to have the grid string. We're destructuring it here. So we have the grid string and the word string. And it's a list, so a two-element list, so we deconstruct it from a list. And we're going to let this be using the function split on new line of the string. Okay, we're using a let here instead of an arrow because this is not in the IO. This is a pure function. This isn't a pure state, so it doesn't have the IO monad. And this one is also pure. So we need to import the split on by importing data list split. All right, so let's take a look at the grid stir and also the word stir. All right, so we see that it is read incorrectly. We want to read into it as a grid. So the grid is going to be just a list of strings. So we're going to take that grid string and we're going to split that on the new line. So now it's just a list of strings. So each line would represent an element in the list. So let's do that, and we don't need the list anymore. Okay, so we could see that the grid is set up properly now. It's just a list of strings. So this way, if I want to say grid 0, 0, then this will return a character. Okay, so we have the grid. Now we need to get the word. So the words, we're going to split it based on the comma. So split on the okay, words. All right, so let's see what that looks like. Okay, this looks okay, except that there are two problems. One is that they need to be uppercased, and there are spaces over here. There's a white space in the front and also in the back over here, the \n. So we need to strip those out. So let's do that. So we need to define a function called trim, and it's going to do something twice, where f is defined to be reverse and drop while is space. So while it's a space, it's going to chop everything off from the front. But then you're going to reverse it, and when you're doing it twice, when you reverse it, you're going to also do it at the end. So that does it twice. So is space, we need to import data.char for the is space function, and we need to map trim on this. Okay, so we see that it's trimmed, but we also need to uppercase it. But uppercasing is done at a character level, so we have to do it this way. So we have to map to upper. Okay, so we have it up in uppercase, and we also stripped it out. Stripped out the white space. So we have the grid set up. We have the word set up. We should also have a list of the coordinates. Okay, so we're going to make this into a list comprehension. First, we're going to get, basically we want the row and column information. This will come in handy because we're going to be using this a few times, so it's nice to have it as some sort of data. But it's going to be stored as lines. So the first row is going to have this, a second row is going to have a list of these, and third row is going to have a list of these as well. So okay, list comprehension. Column is going to be going from 0 through however long the line is. And I'm not going to assume that all the lines are the same, so I'm going to base it on the grid. So length of grid row -1. Since it's 0 based, we have to subtract 1 from it. So this will give me a list of columns, and we'll do this again for the rows. And the row will go from 0 through the length of the grid, -1. So this will be however big the grid is. The grid is just a list of strings. Okay, so let's see. I think I am missing. Okay. Okay, the brackets seem to match now, so let's see the RC lines. Okay, so we see that the first row has all the coordinates, and the second row has the next coordinates. Then we also want chords, which is just a concat of RC lines. So it's just a all in one row chords. So now it's all in one, just one list. And we're going to use this to make sure that the row and column is within bounds. Yeah, so we have all the data necessary. Now we just need to do our search. So we start off with the chords. So we're going to go through each of the chords, and what we'll end up with is a mark, and the mark is going to be a list of row column positions where the letters were found. Okay, actually, we're not going to start with the chords. We're going to start with the words. So given a list of words, we're going to go through each of these and do something. And we're going to go through each of the chords given the word. So there's the word. Okay, and we're going to do something here, and we need to put in the function over here. And I think we have enough. Okay, so it'll be search. We need to pass in the grid, the chords, the row column information. That's the chord, so RC. Okay, so RC represent each element of the chords. Okay, so we have the grid, chords, the word, and we need the path. The initial path is going to be empty. The path is going to keep track of where we've been, and when we start off, it's going to start off as an empty list. Okay, so let's see if this works. We'll just create a dummy search function, taking the grid, chords, RC, the word, path, and we'll just set it to be just the RC. All right, we see that, okay, each of these row column information is a list. And so what we want to do is we want to flatten that. So when we do a search, we're going to flatten it. So at the end over here, we're going to map it, but we're also going to concat. That should flatten it. All right. So let's see. And so these are done for each of the words. So we would like to flatten that as well. So we would say concat of this. Okay, and when we're done, we end up with one long list, and now all we need to do is make the search correct. Okay, so the word, the way that we're going to do this is we're gonna loop through the word. We're going to do this recursively on the word. So if we're given a row column position, that's our starting position, and we're going to look for the first character in the word, and if it matches, then we're going to look for the second character and the third character, and so on until we end up with an empty string. And when it's an empty string, we know that we found the word because all of these have matched, and we end up and as we're going through, we're going to build a path, and all we need to do is just return the path. So we use this pattern here so that if the word happens to be empty, then we're just going to return the path. And the return type of search should be just one list, and path is just one list. So this is okay. The next is we can deconstruct this by splitting it out into row and column. It's still referred to as RC as well. And for the word, we're going to break this up into W and WS. So the first letter of the word and the rest. And for the path, we keep it the same. All right. We're not going to do equal here right now because we're going to use a guard clause. Okay, so the first condition is what happens if it doesn't match. So it wouldn't match it's really when should it stop? And it should stop if the row column information, actually, if the row column information is not in the chords. Okay, this means that it's out of bounds. So the RC is like either less than 0 or greater than the length. Okay, the next condition is if we've already been there. So if the RC is in the path. Okay, the next condition is if the letter didn't match. So we have W, and it's a not. So okay, if it didn't match one of these, the grid position. So we have the row and column. So when we do this, this is the character that's in that grid position. Or it doesn't match the question mark, which is the wild character. So if any of these three conditions do not match, or if we match any of these three conditions, then we know that we should just return empty because we're not successful. Okay, now we have the successful part here, otherwise. Okay, so but when we get to this position, we know that the character matched, and we haven't been there before, and we're in a valid RC position. So we can, and we also know that because of this clause that we're not done. So we need to continue on. So we need to continue on by going through the RC position. So we're going to go in all directions. So first we're going to have the change in row to be going from -1 to 1. And the change in column, we're going to go from -1 to 1. Okay. All right. So what are we going to do here? Well, we're going to do a search, and we're going to pass in the parameters. So these parameters don't change. The RC will change. The row column position, the new position is now row plus R and column plus C. Okay, that's the new row and column position. The word is WS, which is the rest of the word, because we already found the first character. The path is going to be, we're going to add the RC to our path, because now that one was successful, so we just continue on there. Okay, so because this isn't a list comprehension, we should do a concat on this because, actually we don't need that. We should do a concat on this because this is going to be a list of a list, and so we just want it as a list because a search is returning a list of RC, the row and column positions. Okay, so let's see. Okay, everything looks good here, so let's see. We have a parse error in line 5. Okay, oh, we need to put parentheses around this. Okay, so we have some positions here, and now we need to go through and print it out. So actually we can just put it as the print here. Okay, so we have the RC lines, and we're going to convert this into the appropriate character. So we're just going to run through a map here. So we end up with RCs. Okay, so this is going to be a list of row and column positions, and we need to do another map here, and we have the row and column positions and some function here. Okay, all right, so let's see. For now, let's just put in the grid, row, column. So just print out the character. Okay. Let's see. We have, okay, so we're mapping through. Oh, this part we didn't actually specify the list. The list is the RCs. Okay. Expected string. Okay. Well, let's see. Let's do this a little bit one step at a time. Okay. So we just have the row and column positions here, and we're going to map each one of these. It's going to be the R row and column. And let's just return a row. So these are each of the rows. Okay. So instead of the row, we're going to put the okay. So this looks good. And for after we map it, we have a list of strings here, and we're going to use intersperse. Intersperse spaces to this. Oh, intersperse comes from data.list. Okay, that's good. And for each of those lines, we're going to intersperse a new line. Okay. Okay, we can get rid of the show now. Okay, so we have the grid and it's displaying all the grid positions. Now we're going to put a, this line is actually getting kind of long, so let me just do this. All right. So we have the if condition over here. We have the character over here, but we're going to put an if condition. So if the RC, actually we can just do RC over here. So if the RC is in the mark, so LM mark, then we're going to print out the character. Otherwise, we're just going to put a dot. Okay, so you can see that it found these characters, this letter's snaking across, and it does the wildcard character, so Ruby is over here, and RCBY because it's a wild character. And so this has been word search in Haskell.